In Algebra 2, we learned two different ways of attacking dividing polynomials. One of them was called longhand division, which was similar to the process we used in elementary school when we first learned how to do longhand division. The other method was called synthetic division. The only problem with synthetic division is there are only certain circumstances under which you can use it, and we'll talk about that in a few. So let's start with reviewing how longhand division worked. I want to divide 6x squared minus 26x plus 12 by x minus 4. Remember, this is called the divisor. And the divisor is the part that goes on the outside of the, of the little division symbol. This part here is called the dividend. And we want to find the quotient, which is the answer to a division problem. Now, the way that this worked was because there are two terms on the outside of the division bar, we want to know how many times x minus 4 goes into 6x squared minus 26x. Really, all you have to do is you have to determine what you have to multiply x by so that it becomes a 6x squared. Because we just want to get rid of the first term every time we do our subtraction. So I need to multiply by 6x. So I multiply the divisor by 6x. I get 6x squared minus 24x. And then we subtract these. Well, 6x squared minus 6x squared cancels. Negative 26x minus negative 24x is negative 2x. Bring down the next term. One of the things you need to watch while you're doing your division is your signs. Alright, so now we want to find out how many times x minus 4 goes into negative 2x plus 12. All we have to do is figure out how I turn the x from the divisor into a negative 2x. Well, you multiply it by negative 2. So to multiply the divisor by negative 2, and I get negative 2x plus 8, and then we subtract. These should always cancel. 12 minus 8 is 4. And that's my remainder. Now, instead of using the r for remainder, what we do is we tack on a plus sign at the end of the quotient, and we write the remainder divided by the divisor. And this is how we're going to appropriately write the quotient at the end of the problem. Now, you'll know that the fraction at the end of the quotient is the remainder because it looks funny. Let's do a little bit more complicated division problem, one more apt for an honors class. We want to divide 8x to the 4th plus 6x squared minus 3x plus 1 by 2x squared minus x plus 2. One of the things you need to be cautious about when you're doing division is, are there any missing terms in the polynomial? In order for division to work, you need to have whatever your highest exponent is be the first term. Each consecutive term, the exponent of x should go down 1 in power. So if you look at the dividend, you'll notice right away that there's no x cubed between the x to the 4th and x squared. We're going to have to put an x cubed in its place. And since it's really not there, its coefficient must be 0. So we're going to put the divisor 2x squared minus x plus 2. And then the dividend is going to be 8x to the 4th plus, let's make that look nicer, 8x to the 4th plus 0x to the 3rd plus 6x squared minus 3x plus 1. Now we can go do our longhand division. Since there are 3 terms in the dividend, we want to know how many times it goes into the first 3 terms of the divisor. We want to make a 2x squared turn into an 8x to the 4th by multiplying by something. Well, I'm going to have to multiply by 4x squared. So when I multiply the divisor by 4x squared, I get 8x to the 4th minus 4x to the 3rd plus 8x squared. And you'll notice that all these like terms match up right underneath, which makes it really nice for subtraction. The first terms better cancel. 0 minus negative 4 is positive 4, x to the 3rd. 6 minus 8 is negative 2x squared. Bring down the next term. Okay, now to make the 2x squared into a 4x cubed, we need to multiply by positive 2x. So I get 4x to the third minus 2x squared plus 4x. And then we're going to subtract. So these go away. Negative 2 minus negative 2 is 0, and I'm actually just going to leave that as 0 right now instead of canceling it out. And then negative 3 minus 4 is negative 7x. Bring down the next term. Alright, so now this is the last one I have to do. I'm going to move the screen up here a little bit. I need to turn the 2x squared into a 0x squared. Well, that means there must be a plus 0 here at the end. So you have 0x squared minus 0x plus 0. You subtract, and you end up with negative 7x plus 1. That's your remainder. That means that the final answer must be 4x squared plus 2x plus negative 7x plus 1 all over 2x squared minus x plus 2. One of the things the book talks about is writing this in a kind of factored form into p of x, the original polynomial, is equal to d times q plus r, where r is the remainder, q is the quotient, and d is the divisor. And so another way of writing this answer in factored form is as 2x squared minus x plus 2 times 4x squared plus 2x plus negative 7x plus 1. So if they ask you to write the division in that form, that's really all they're asking for. It's relatively simple. Now let's review synthetic division from Algebra 2. Synthetic division was the one where you have a little number you put in a box. Different textbooks do it in different ways. Our textbook uses a little bit of different notation when they write it. The way that I like to do the problem is I like to take the divisor, set it equal to 0, and solve for x. That's the number that's going to go in my little box. Next to the box is going to be the coefficients from the dividend. But again, you have to watch out for missing terms. If you look at the dividend, the first term is x cubed, the next term is x squared, but you're missing an x to the first. So we're going to have to put a 0x to the first in there. So the coefficients are 2, negative 7, 0, 5. And you give yourself a little bit of space. I tell the Algebra 2 kids to put their pinky between the coefficients. One of the things that sometimes happens is if you try to write it too small and you smush the numbers in too close, sometimes you'll think that a 1 and then a 0 is a 10 instead of a 1 and a 0. So give yourself some space when you do these problems. The way that it works is the first coefficient gets dropped below the line. Then you have to put a number under the negative 7. To get that number, you multiply the box times the number under the line. 3 times 2 is 6. And then you add going down. To get the number that goes under 0, you multiply the number in the box by the number under the line. And then you add going down. To get the number under the 5, you multiply the number in the box by the number under the line. And then you add going down. The last number is always the remainder. And this is the quotient. The quotient will always be 1 power less than the original problem. So the original dividend started with x cubed, so the quotient must start with x squared, minus 1x, and then minus 3 with your remainder of negative 4, or we like to write it as 2x squared minus x minus 3 plus negative 4 over x minus 3. Or if you write it in the other format, which was divisor, quotient, plus remainder. Either way is acceptable to me. Now, one of the things I want to go back and point out is why we could use synthetic division here. Synthetic division can only be done when the divisor is in the form x minus a number or x plus a number. In other words, I don't want it to say 2x minus 5. I don't want it to say x squared plus 11. Problem back here, we could not have done using synthetic division because the divisor had a 2x squared, and it had 3 terms instead of 2. In order to do synthetic division, the divisor has to be a binomial, and it has to start with an x to the first. Otherwise, synthetic division is not an option for doing your division. The remainder theorem is a pretty useful theorem. It says if the polynomial p of x is divided by x minus c, then you can find the remainder by simply plugging c into the polynomial and evaluating. So let me prove this to you. Let p of x equal 3x to the 5th plus 5x to the 4th minus 4x cubed plus 7x plus 3. Find the quotient and the remainder when p of x is divided by x plus 2. Well, let's go do this using synthetic division since this particular polynomial is set up in that format. So you take the divisor, set it equal to 0, and solve. That's the number that goes in your box. Next to the box are the coefficients of the original polynomial. I want you to notice that there's an x squared missing, so we need to put 0 in its place. So the coefficients are 3, 5, 4, 0, 7, and 3. The first number gets dropped below the line, and then I put a negative 6 under the next term and add going down. I put a 2 under the next term and add going down. Negative 12 and then add going down. 24 and then add going down. And then negative 62 and then I add going down, which I believe is negative 59. So the quotient would be 3x to the 4th minus x cubed plus 6x squared minus 12x plus 31 with a remainder of negative 59. However, I should get this right because what I forgot is that this should have been a negative 4, which means that starting here, all this stuff got messed up, and I am sorry because that sometimes happens. Alright, let me go back and try that again. That should have been a negative 4 if I look back at my signs. So here's the lesson. Watch your signs. I clearly did not. Alright, when I add, I get negative 2. This is a 4. This is a 4. Negative 8. Negative 1. 2, and then 5. Alright, that's a little bit better. 3x to the 4th minus x to the 3rd minus 2x squared plus 4x minus 1 with a remainder of 5. Okay, now let me go back to what I was going to say, which was, I claim to you, if you find p of negative 2, you're going to find out the answer is 5. That means if you plug negative 2 into the original polynomial, which was, 3x to the 5th. So we're going to do 3 times negative 2 to the 5th, plus a 5 times negative 2 to the 4th, minus 4 times negative 2 to the 3rd, plus 7 times negative 2 plus 3, and then you type it into your calculator, you hit enter. You will find out the answer is 5. So that is the remainder theorem. The other theorem that we talk about, the factor theorem, says that c is a 0, or an x-intercept of a polynomial p if and only if x minus c is a factor of p of x. And how do we know something is a factor? We know it's a factor if we perform polynomial division and the remainder is 0. That's how we're going to know something is a factor or not. So let p of x equal x cubed minus 7x plus 6. Show that p of 1 equals 0 and use this fact to factor p of x completely. Well, to show that p of 1 equals 0, you have to plug in 1 in place of p. So is 1 to the 3rd minus 7 times 1 plus 6 equal to 0? Well, you get 1 minus 7 plus 6, which is 0, and it does. If 1 is a 0, then x minus 1 is a factor. Okay, so now I know that x minus 1 is a factor. In order to factor this completely, I'm going to perform polynomial division to find out what the quotient is. Now in order to do that, 1 is what goes in my box. Let me use a different color. Put 1 in my box. And next to it go the coefficients from p. Notice that there's a missing term. So the coefficients are 1, 0, negative 7, and 6. 1, 1, 1, 1, negative 6, 0. So the quotient is x squared plus x minus 6. So in factored form, the polynomial is x minus 1 times the quotient, and there's no remainder because the remainder is 0. We can use the factor theorem to find the original polynomial if we know the zeros. So the zeros are where the polynomial is equal to 0, or where the remainder, if I did division, equals 0. So if negative 3, 0, 1, and 5 are the zeros of a polynomial, those are the x-intercepts, then I know that the factors are x plus 3, because x minus c would be x minus negative 3, x minus 0, which is really just x minus 1, and x minus 5. So how am I going to multiply this out? Well, you kind of have to do it in parts. You can only multiply two of the binomials together at a time, so I would start with these. I'm going to skip steps because at the honors level, you should be able to tell me that that is x squared minus 6x plus 5. I'm going to multiply these two together, so I get x squared plus 3x. Now I'm going to have to multiply these together, and I need to be careful when I do my distribution. The way that I like to do it is I like to start by distributing the first term. I get x to the 4th minus 6x to the 3rd plus 5x squared. And then I'm going to distribute the second term. I get 3x cubed minus 18x squared plus 15x. And then I look for like terms. Well, x to the 4th, being the largest term, has no like terms. However, there are two terms with x cubed, so I get minus 3x cubed. There are two terms with x squared. I get minus 13x squared. And there's nothing that goes with the 15x. So the polynomial, that if I were to graph it, hits the x-axis at negative 3, 0, 1, and 5 is x to the 4th minus 3x cubed minus 13x squared plus 15x. And that was section 3.3 on dividing polynomials.